All right, so my name is Mark Voelker. I'm a tech lead at Cisco. I've been working at OpenStack for a while now. I'm a Puppet StackForge core developer. And generally what I do is a lot of deployments of OpenStack. So I support various of Cisco's internal and external customers, building their clouds, helping them architect them, all that sort of fun stuff, and actually working with the code as well. I work in the cloud and virtualization group at Cisco. Have had various roles over the past several years in that capacity. I got started in OpenStack in 2011 and have been doing this ever since. This is kind of what gets me up in the morning. So it's fun in that I get to explore a whole lot of different things about clouds, not just OpenStack, but all kinds of clouds and things that people are using clouds for. And I get to build a lot of them. So very small ones, very large ones, kind of everything in between, which is fun to see. This is not like a super formal talk. I'm not wearing a suit and tie. I don't bite either, so if you have questions, then I'm happy to answer them. We do have a whole lot of material to get through in the small time that we have today, so I'm going to run pretty fast through this. These slides are going to be available on the ATO website afterwards, probably in the next couple of days, and I'll put them on SlideShare as well. So there's a lot of links inside these slides, so feel free to go download them, click on those things that interest you, and find more information that way as well. So I'm going to move pretty quick, so buckle your seatbelts. OpenStack. So this is a report from Forrester Research in the spring of earlier this year, where they basically said that OpenStack is now pretty much a must. And this is borne out by pretty much every cloud survey that I see. People are pretty excited about OpenStack, which is great. But then how do you actually go about running an OpenStack cloud? Because clouds are actually pretty complex. Clouds are pretty simple for people that are using them because they have a very simple API or a very simple portal where they say, I want a server now, or I want a network now, or I want a storage volume now, and it just happens. But for people that are administering clouds, there's a whole lot of stuff going on under the hood. So if you're actually running a cloud, this is a little more complicated for you. That's true regardless of almost any cloud platform. So if you attended the talk earlier this morning that I just got done doing, and hopefully have my voice back from, then you already know how to get to day one, and you already know a little bit about OpenStack itself and all the different technical components. We're not going to cover that here, because that would be a lot of repetition. We're going to talk about how to build a cloud that you can actually maintain over time, because very few people actually want to spin up a cloud just for a day. So a few things that we're going to talk about. Let's start off with architecture. So high availability, that sounds good, right? Everybody likes highly available clouds. When you talk about architecting high availability into OpenStack, one of the first things that comes to everybody's mind is whether you're doing active-active or active-passive. And the reason that that is a choice is because there's different technologies to implement those things. And it kind of changes the components that you're going to use depending on which way you go. The setup and tooling is going to differ a little bit depending on which of those paths you choose. They're both perfectly valid depending on what your requirements are. I built clouds with both. Generally, most of the customers that I work with and most of the clouds that I build have an active-active control plane, which is entirely possible to do with a few small caveats, which we'll talk about in a little bit. Note that there is now an HA guide on docs.openstack.org, and you should go check it out. It details in a lot more detail than you're going to find in these slides today, given the amount of time that we have, how to set up an active-active or an active-passive control plane for your clouds. They're a little bit dated, so patches are welcome. It is a great way to get involved in OpenStack, to go look at those docs, find problems with them, and submit patches to them. That, by the way, will actually get you an active technical contributor badge, and that will get you into an OpenStack Summit for free. So there's bait. And that happens regardless of whether you're contributing code or whether you're contributing changes to the documentation. So awesome way to get involved. So when we talk about high availability for clouds, there are a number of different things that we could sort of be talking about there. What we're not talking about here in this case is high availability for instances. In other words, when a customer spins up a VM, we're not necessarily talking about making that VM highly available. At the end of the day, if the server that thing is running on drops off the face of the planet, it will not magically reappear in a second. There's actually work that has to be done, right? What we're really talking about here is prioritizing the control plane. So this is things like make sure the APIs are always available. Make sure the things that they're talking to you on the back end, the schedulers and those things are always available. Because those are the things that people are actually interacting with day to day. In a lot of cloud applications, they actually don't care that much if instances die because their applications are built to withstand failures, and they will just spin up more instances. But they can only do that if the API server is available, right? So that's kind of important. So when you're talking about an active-active control plane, that actually means a couple things under the hood that aren't OpenStack themselves, you're certainly going to want to put up a load balancer and put multiple API servers behind it so that if one of them dies, then your load balancer takes care of routing traffic to one of the ones that's still live, right? But OpenStack has a couple of underpinning components that are used as well. Databases, RPC buses. Those things also need to be highly available if you're going to have a highly available control plane. So let's see. I mentioned instance level HA. Russell Bryant, who's the former PTL of the Nova project, actually just this past week published a blog post about some thoughts about how we can get to instance level HA. So if that's interesting to you, you should go download these slides, click that link, and go for it. It's kind of the pets versus cattle debate. Most of the workloads running on OpenStack clouds right now are not what we call pets. That is, they are designed to tolerate failure, and if servers go away underneath them, they don't care that much. They respond to that and build themselves back up. Not all of them, certainly, but there are a lot more cattle out there in clouds today than there are pets. One kind of note, if you are going to build a highly available control plane, it's generally going to involve more hardware than it would if you're not doing an HA control plane. You're going to want to do things like, for example, if I'm running a Galera database as my database backend, I need at least 3 nodes to have high availability. 2 is not enough because then I have split brain scenarios and you don't want that. So you need at least 3 nodes for that, right? Whereas if you weren't doing HA, then you could probably get away with a single database node. You really wouldn't want to, but anyway, just be aware of that when you're doing your planning. So a little more about the underpinning stuff. Things that OpenStack needs to run include message brokers. So RabbitMQ is kind of the one that we see most often in the field. As we go through this talk, I'll kind of talk a little bit about the things that I see most often when I'm building clouds. That doesn't mean that they are the only valid choices. There are certainly plenty of people out there, for example, who are using Cupid instead of RabbitMQ. But just as far as kind of reference cases, RabbitMQ seems to be a little more popular. RabbitMQ has clustering and mirrored queues built into it. There are a few caveats about that, but that's generally how you're going to get HA for your RPC bus. And again, the RPC bus is basically used for components within an OpenStack project to talk to each other. So this is what the Nova scheduler uses to talk to the other Nova components, for example. Database backends. So check out Galera if you want to do an active-active. Generally, what I see out there is mostly Percona X3DB. That is actually packaged now on Ubuntu 14.04, whereas it was not in 12.04. So if you moved to 14.04 recently, you can actually get Percona installed pretty darn easily. That's made it pretty popular as a Galera choice. There are others. Codership has another implementation of Galera out there, so you can go check that out as well. Generally, what we're going to do is front-end those with an HA proxy pair. So a pair of load balancers that are running keep live D between them so that if one of the load balancers dies, then you also don't have a problem, right? And again, this is probably going to involve at a minimum 3 nodes on the back end to support the replication between them. When you're talking about Galera, there are a few caveats, and there are also a few caveats with Rabbit clustering. With Rabbit clustering, one of the things you do not want to do is set that up over WAN links. May seem surprising because you think about cloud and you think about a data center, but it turns out people want multiple data centers for availability reasons. You probably don't want to do this over a WAN link. RabbitMQ's clustering services don't really tolerate partition networks very well. When you put it over a WAN link, things are going to go bad fast. The other thing to be aware of on the database side is the select for update issue. So let's talk a little more about that. So Galera is kind of the default choice for most people implementing OpenStack with an active-active database on the back end. For those of you who don't know, it's kind of a layer that rides on top of MySQL or MariaDB, and it performs active-active synchronization between disparate nodes, rather than sort of the old master-slave replication technologies, right? And it's a synchronous technology as well. Long story short, the fact that it is synchronous and running over many nodes kind of puts some constraints on behaviors. And it turns out one of the things it does not handle very well is a SQL pattern called select for update. I won't go into the horrible details of databases. I'm actually not a database guy myself. But basically what happens is the locks don't get distributed across all the nodes properly, and you can wind up deadlocking a database that way. So for a while, people that were building OpenStack clouds with active-active Galera on the back end were kind of occasionally seeing these deadlocks, and nobody could quite figure out what was going on. And then when we were in Atlanta, Jay Pipes was talking to one of the Percona guys, Peter Boros, and they were kind of just chit-chatting back and forth and kicking around ideas about this deadlock issue. And Jay mentioned, I wonder if it has anything to do with select for update. And they were like, yes, it does, because we don't support that. So that kind of became a thing. OpenStack under the hood actually doesn't do raw SQL calls. It actually runs through an ORM layer called SQL Alchemy. So I think a lot of people actually didn't realize that we were actually doing select for update to begin with. So this was kind of like one of those light bulb moments where it was like, oh, that's what it is. So that code is now being refactored. It actually was only present in Neutron and some parts of Nova, and it's now being refactored out of the code base so that this will go away and no longer be an issue. That said, especially on the Neutron side, it's a pretty heavy refactor, so it's probably going to take until at least Kilo before it's out. The new Juno release that was just released in the past week or so is actually still vulnerable to this. So does that mean that you can't use Galera as a backend anymore? Actually, no, it doesn't. It just means you have to be careful about where you do your writes. The way that we work around this is we basically use HA proxy or some other load balancer in front of your Galera cluster to send all the writes to a single one of those nodes. Obviously, that's a bottleneck. Turns out for most people, their clouds are still small enough where this doesn't really matter very much. So it's not a huge thing unless you're running a really, really big cloud today. Like I say, probably in the next 6 months or so, we'll have a release out that gets rid of this problem entirely. But if you're building Galera on the back end, this is something that you should be aware of. Other HA notes. So glance is where we store our images. That means you're actually writing data to a disk somewhere. You probably want to use a highly available backend for that as well. So something like Swift or Ceph are supported backends for glance. Those are distributed data stores. So if nodes die, then things just keep working. You also want to pick a reliable backend for Cinder as well. A lot of different technologies there, but the basic concept is the same. If a part of your storage infrastructure dies, you want it to be still available. So probably you don't want to be using LVM to local disk for this. Multiple API servers. So we kind of touched on this a little bit earlier. We use Keep Alive and HA Proxy to kind of front-end API services. Basically, this is equivalent to setting up a pair of load balancers that are running VRRP or something between them so that if either load balancers dies, IP addresses get shifted around and things just magically keep working. Other load balancer technologies are fine. HA Proxy and Keep Alive D are just what I see in the field a lot. So there's a lot of community wisdom around how to build those things, and you'll see that in the HA guides as well. So it's a good place to start. Not to say other technologies can't certainly be used. Let's see. So on the networking side, is kind of an interesting piece. Most clouds that are being built today are being built to use Neutron for the networking layer and not the old Nova networking, because we sort of know that that's on its way out. So if you're building a new cloud today, you're probably using Neutron. Neutron's layer 3 agent that provides the Neutron routers is not highly available today. In the Juno release that just came out last week, we have a new thing called DVR, Distributed Virtual Routers, which will solve that problem by allowing you to spin up distributed routers and do VRRP between them. It's still in a pretty rough state right now, and not even the Neutron devs are recommending that you put that into production today. It's there for people to start kicking the tires, playing with it, finding the bugs, so that maybe when Kilo comes out, we have a pretty solid implementation. But that is brand new, hot off the presses stuff. So for generally what I've seen in the field today for doing high availability on the network is to punt. There's a thing called provider network extensions in Neutron, which basically says let the cloud administrator punt this directly down to the physical network. So that's actually where cloud administrator is going to come in and dedicate some VLANs or those kinds of things, and we're going to talk directly to those rather than going through the Neutron routers. It actually has some performance advantages because you're no longer going through a NAT layer. So people like them for that reason if they have network performance issues anyway. So people have been using these for a long time for non-HA reasons as well. But once you're punting to the physical data center network, you can actually do things like have switches that have virtual port channels across multiple nodes, or do VRRP between routers in your network. So that's kind of the way that people get around that today. Okay, bare metal bring up. So when we start building a cloud, generally we don't have a thing already there. We actually have to put servers in racks and build a cloud. So where we start is always with sort of the bare metal. And if you're building a cloud of any size, like greater than 2 servers, you probably don't want to go touch all those nodes and configure things manually and put operating systems on them manually and stand all day in front of a keyboard in your data center. It's cold in there. So there are tools to help with bare metal bring up. This actually, I should note, this is actually not just a day 0 problem, because it turns out people actually want to add capacity to their clouds over time and remove capacity and cycle hardware and do those kinds of things. So this is a problem you're going to have continually once you have a cloud up and running. So it makes sense to think about this early on. You can also use them for other things too. Inventorying and bootstrapping and things like that are also things that can be met. One example, Cobbler is a tool that a lot of people use. This is what I see probably more than anything else in the field right now when we're building clouds. So Cobbler is a small piece of Python code, smallish piece of Python code. Has an API, has a CLI, has a GUI. It's been around for a while. It's available in all your mainstream Linux distributions. And basically, it kind of coordinates a whole bunch of services like TFTP, running web servers, running DNS mask to do PXE boot of servers and getting operating systems installed on them. So it does the job. It does it pretty well. And like I say, it's pretty widely available. It also handles power control as well via IPMI or other tools. So for example, I'm a Cisco guy, so you can actually use Cobbler to talk to Cisco UCS gear through the Cisco UCS APIs to do power control. So that allows you to do everything from literally pushing the power button on the box to bring it up. Couple of quick basics. I won't go into a whole lot of detail because we don't have time. But basically, when you build out Cobbler, you'll define systems in Cobbler. In this case, I've defined 4 compute nodes and a control node. And then if you look at the definition of what one of those is, this is what my control node definition looks like, for example. And you can kind of see, I know that it's kind of fine print here, but you can kind of see things like I've told it where the power management address is and what passwords it needs to use to log into that and what tools it should use to do that with. In this case, it's IPMI tool. And I've also assigned it a profile and given it a pre-seed file so that when I use Cobbler to push the virtual power button on this box, it's going to boot up. It's going to do a PXE boot on the network. There's going to be a PXE server there to respond to it. It's going to give it an Ubuntu image and tell it how to partition its disks and what IP addresses it should have and all that kind of stuff. And it just happens, which is very nice. There are plenty of alternatives. Again, Cobbler is one that I see a whole lot in the field, but there are certainly others out there, and some of them are actually pretty cool. So, if you're looking for a place to start, there's plenty of community wisdom around Cobbler. You will see some of these other ones as well. Foreman especially is used by Red Hat these days. So, you'll see that one out there definitely. There's also Crowbar. This was kind of originally written by Dell, and it's now totally a community project. They've actually kind of backed off of it now, and it's maintained entirely by the community. But again, the concepts are all the same here, pretty much. These are tools that you're going to use to start from a box that you've just taken out of its shipping crate and get an operating system put on it and get it provisioned for OpenStack. Config management. OK, so this is a hot topic. I think you all came for an OpenStack talk, and now we're talking about things like provisioning, and we're talking about things like configuration management. And this is starting to sound a lot like a DevOps talk. Which is actually kind of case in point. Most of the clouds that I see built today, people are not just putting more software in their data centers. They're actually changing the way that they do things. And for a lot of them, that means that they're getting into DevOps for the first time. DevOps is a really loaded term. I'm sure you've heard it used in all kinds of contexts, especially here this week. But in general, one of the concepts here is that you want to automate as much as you possibly can. We don't want to go, we just talked about this, right? We don't want to go in the data center and stand in front of a keyboard to provision our nodes. We want to do that remotely. And we want to do it with an API. And we want to do it as fast as we possibly can. Logging into servers and messing with config files, especially in clouds that are hundreds or dozens or even more than one node, makes me sad because there are just better ways to do it. So this is why we're going to talk about configuration management. So think about why to use a configuration management tool now. First thing to remember is that OpenStack is a whole bunch of distributed systems that work together. Not just one distributed system, but a whole bunch of them that work together. And if you've ever been in charge of a distributed system, you know that that generally involves a whole lot of nodes to touch. And that means a lot of SSH sessions if you're going to try to do things by hand, and a very high probability that you're going to get something wrong somewhere. So using a configuration management tool is a big plus for distributed systems, especially when you have a lot of them that are trying to work together. It does mean that there's a lot of software to be installed as well, not just configured, but also installed. And a configuration management tool will take care of that for you. You're probably going to want to make changes over time. I know very few clouds that don't make changes over time to their configurations, spin up new services or disallow old services or various other things, even change the configuration of the bare metal operating systems. Configuration management tools are built to do that kind of thing. So if you get that in place today, you'll be much happier down the road, and it's worth the initial investment. You're probably also going to have more than one person touching a cloud. I know of very few clouds that are administered by a single person, and those that are very much in danger of buses causing problems for them when that person walks across the crosswalk at the wrong time. So configuration management tools allow you to collaborate very easily because you're keeping your configuration management in some form of text at the end of the day, whether that's a Puppet manifest or a chef recipe or what have you. You can actually keep those in code review tools. You can actually collaborate on them and do code reviews on them the same way that developers do on code. And that makes it a much more concrete way to do collaboration for configuration. Tools, there are a lot of good choices. So Puppet and Chef both have a pretty big footprint in the OpenStack community. Ansible's out there now as well. There's some older ones like CF Engine, Salt Stack. There are piles of bash scripts that are administering clouds today, and I don't recommend that as a choice. But there are other good choices. So the good news is that you're going to be spoiled for choice. This is the results of the most recent OpenStack user survey. We do this every 6 months before the design summits. One of the things that is asked about is what are you using for deployment tools in production? When they say deployment tools, they actually usually mean configuration management tools too, because they kind of serve both purposes. Most people that are managing configurations with Puppet also deploy their software with Puppet. So you can kind of see the breakdown here. This is for production. There are, if you go look at the user survey, you'll also see kind of the same slide, but for POC environments and also for just messing around environments. But in all of them, the results look fairly similar. So you can kind of see there's a whole lot of Puppet going on today. Kind of makes sense. Puppet's been around probably longer than most of the others, and a lot of people have existing investments in Puppet and in-house knowledge in Puppet already. But there are certainly others out there as well. I should mention, if you look kind of at the bottom tier there, some of the tools down there are actually written in other things. So if you look at PackStack uses Puppet under the hood, right? So the numbers are kind of a little bit weird here. Crowbar uses Chef, and so forth. But generally, those aren't huge numbers, so you can kind of see the general trends pretty easily. The other thing to note is that you don't always have to choose one. This is actually something that we see increasingly commonly nowadays. In fact, most of the clouds I work with today are actually using more than one. Reasons why? Well, Puppet does its job pretty well as a configuration management system, in my personal opinion. And if there are Puppet people in the room, please don't throw tomatoes at me. It does not do cross-node orchestration very well. There are things in OpenStack where you're going to want cross-node orchestration, where you want something to happen on this node before something happens on this node. A classic example of that is when you're deploying Swift. You initialize a ring on one server, and you're supposed to sync it out to the other servers. If you try to start up Swift before that ring sync happens, Swift won't start up. So that's a classic case of, I want something to happen over here before something happens over here. So what a lot of people have started doing for that use case is to use Puppet or Chef for the configuration management piece, and then to use something like Salt or Ansible for the orchestration piece. Ansible and Salt are kind of newer generation tools, and that's a use case that they've covered pretty well. I know the Ansible guys are running around here at the conference today, so go say hi to them. The basic recommendation here, I will not stand up here and tell you that you should do one or the other. I use Puppet a lot. I'm a core dev on the Puppet StatForge project. It works for me, and it works for a lot of people that I work with. And usually it's them coming to me and telling me that they want to use Puppet. So we do that. And like I say, I also use Ansible a lot for an orchestration layer. Use the tools that work for you. A lot of times you're already going to have an investment in one of these tools in your IT infrastructure. And if you already have in-house knowledge, that's probably a good place to start. Links for later. There are communities around most of these tools in OpenStack that are teams of people collaborating on manifests or cookbooks or whatever. And there's some links there that you can go check out later. I do not have any links to big piles of bash scripts. I tried to hide those from people. Testing. So when you're doing any kind of configuration management tools, the cool thing is that you can deploy stuff really fast, and you can get it right a lot. You can also break things even faster. I don't recommend generally putting your network configuration under the auspices of a Puppet agent, because if you break the networking, you can no longer talk to the Puppet master, and then your whole world is broken and very sad. So tester code. Unit tests are a great thing. If you look at, for example, the Puppet community in StackForge, they actually write RSpec tests, Puppet RSpec tests for all the functions that they have in their manifests. So there's kind of a level of assurance that as we make changes over time, we're not totally breaking the world for you. Server spec tests are also a great way to go. Server spec is essentially a layer that goes on after configuration management has run, regardless of what that configuration management is, whether it's Puppet, Chef, or what have you. It actually goes to your server and says, I was supposed to configure the server to look this way and have this service running and this config file looking like this. Does it actually have that now that my configuration agent has run? So this is a good way to kind of dummy check and make sure that your configuration management system actually did what it was supposed to. Let's see. So yes, test all those things. CICD. Okay, so when we talk about continuous integration, continuous deployment, a lot of times we think about developers. And this talk was supposed to be about running clouds, which sounds a little different from developing clouds, right? But everybody likes a butler. So reasons to think about CICD today. DevOps is actually a pretty handy thing. And if we're doing configuration management anyway, and we're treating our manifests or recipes or playbooks or what have you as code, pretty handy to actually think about a continuous integration system so we can actually test those things in real time as well with every change that we make. And even deploy those things in a more automated manner as well. So this is kind of the next level of automation in your data center. The more investment you put on this stuff early on when you're building clouds, the happier you will be in the long run. Trust me on this, I've seen this a few times. So that said, OpenStack has a huge change velocity. We get thousands of patches a day on peak days. It's crazy. Not necessarily all those you're going to deploy into production immediately, certainly, but we do release patches to stable branches pretty frequently. You're going to have to find a cadence that works for you. It's different for everybody. Some people are going to leave things alone for 6 months. There aren't very many of those. Most of them actually want hot fixes and things a little faster than that. So a CI system is actually a good way to go about getting those things done. Also, it's worth noting the majority of the deployments of OpenStack that I work with have some form of local patches in them. Whether that's I want to disable this entire feature because I don't like the security of it, or I want to add this feature that doesn't exist upstream yet or won't be available until the next release, or I backported something from a future release and I'm running something older. The vast majority have some level of local patches to them. And I say some level, it's usually not very much. We're talking like a handful, 10 or 20 patches. Maybe a driver fix for Neutron or something along those lines. But that said, if you're going to do that, you probably want to run those code changes through tests. And you probably want to get them deployed in a way that makes sense as well. And CI tools are great ways to do that. And don't forget that it's not just OpenStack necessarily. Some of the underpinning components too. We do have databases. We do have RabbitMQ. We do have all those other things that are out there, the Python libraries that run OpenStack itself or some of those other tools. Continuous integration servers actually do a pretty good job of being able to give you a harness to test all that stuff together when any of those things change. So big advantages here. Jenkins, Travis, Go, there's plenty of others out there. Jenkins is kind of the default way to go. It is actually used by the OpenStack development infrastructure itself. So we had someone give a talk earlier today. Elizabeth Joseph gave a great talk yesterday about some of the work that goes on in the OpenStack CI world. OpenStack runs these tools themselves for developers. So every time I submit a patch to OpenStack, the first guy to comment on it is Jenkins. And more often than not, he tells me I did something wrong. But that's usually my fault. So there are some awesome tools that the OpenStack Infra team has developed to maintain that patch velocity. Things like Jenkins Job Builder, Zool, which runs jobs concurrently and then does back off if some of them break. So these are all good things to look at. There's a lot of wisdom around this in the OpenStack CI world. You should definitely take advantage of it. It's pretty well documented. You can actually go get all their configurations and code and all that stuff. So it's a great way to go. There's hopefully before I upload this, Elizabeth's slides will be live somewhere, and I'll link to those as well. Basics in terms of what you need for a CI infrastructure, you need some kind of integration server. That's usually Jenkins for about 99.9% of the clouds that I deal with. Some kind of code review tool. We use Garrett in the OpenStack world mostly. There are others. Some kind of battery of tests, whether that's lint checks, which are pretty simple and stupid. RSpec Tests for Puppet. There are similar things to the other configuration management tools. Tempest and Rally are testing frameworks that we use for either scalability or basic functionality to make sure all the APIs are working and that kind of thing. Some form of packaging. Generally, I don't deploy code file by file. I deploy it as RPMs or as debs or what have you. So we actually use packaging. In many cases, there's an artifact repository. It could be something pretty fancy like Artifactory, or it could be something as simple as once you build the code into an RPM, stick it into a Yum repo for me. Both those are out there. Optionally, some kind of deployment jobs if you're actually going to do CD, continuous deployment as well as CI. A lot of times you'll have some kind of hook in there to actually deploy stuff once it's out there. And generally that will be a little nuanced because you don't always want to deploy everything to your entire infrastructure right away. So that said, CI/CD is not for everybody. There are certainly customers that I work with where this breaks their view of the world and they go cry in a corner. So for deployers, it's not necessarily the best thing for everybody. So there are reasons why it might not be for you. If you've never intend to change code yourself and have no confidence that you can learn Python, which you should because you can, then the CI/CD may not be as appealing to you. If you're in a situation where you're heavily reliant on a support contract from whoever provided your OpenStack distribution, and you're going to go change all the code, they're probably not going to support you anymore. So that might be a reason not to do CI/CD. You can still kind of take advantage of the integration, running somebody else's OpenStack packages with your own custom app code or your own custom deployment code, but it does make it a little less appealing. If you've never used a CI/CD pipeline before, it can be a little overwhelming at first. So you really should learn this. This is kind of the way things are going. This is the trend for the future. And like I say, the initial upfront investment is usually worth it. But if you're under some kind of time constraint and you've never used this stuff before, there's going to be a ramp-up curve. And finally, if you have a static environment that will absolutely never change, this also might not be for you. And when I see that, usually is where people are embedding OpenStack in some other product where it's kind of a piece of the engine under the hood, and that thing is never going to change. So it's a containerized little appliance or something where the customer doesn't actually even know that they're running OpenStack. In that case, CI/CD may not be as much for you. Monitoring. How are we doing on time here? Okay. So now that you have a cloud, you probably actually want to keep an eye on it and make sure that things continue to run, because it turns out in data centers things happen. I think the example yesterday was that sometimes people throw elbows at server racks, and that causes bad things to happen. So you want to keep an eye on things in your cloud. So what monitoring tools should we use for OpenStack? The classic question that we always get at any operators meetup is, what tools should I use to keep an eye on things? Because there's a few choices out there. These ones are all open source, by the way. There are others that aren't. So it's even broader. Yeah, not going there. Sorry. The thing about monitoring tools is that more than any other thing in OpenStack, in all the cloud deployments that I've seen, this is the thing where everybody does it differently. Probably upwards of 80% of the clouds that I've built use Rabbit. Probably upwards of 80% of them use MySQL or Maria. When it comes to monitoring tools, it's all over the freaking map. So I can't actually sit here in front of you and tell you that this one is the one that you should use. That said, people seem to like Graphite pretty well. That's probably the one that's pretty common. But that's really a small piece of the general puzzle. Graphite basically is what's going to consume trending data and spit out pretty graphs for you so that you know what's going on in your infrastructure. It's not the thing that's going to page you when an API server goes down, right? So it's kind of a small piece of the puzzle. The golden rule is basically use the tools that work for you. Chances are, if you're building an OpenStack cloud, you've already got some other IT infrastructure that you're watching over or have in the past. Chances are that you've used some monitoring tools with that before. That's probably a reasonable place for you to start. The other thing I'll say is use your peers. There is an operators alias. There's an operators community in OpenStack. There are people there who will rant for days about how horrible Nagios is and how you should never use it. And then they get into fights with the people who like Zabbix, and it's fun to watch. Bring popcorn. Tong here has actually a talk about monitoring as a service later today. So if you're interested in monitoring and OpenStack and clouds, you should probably come to that talk. It's going to be good. The other thing is generally, I find it helpful for people to kind of break down, when they say monitoring, that's a pretty big bucket. If they break it down into at least 2 buckets, then that kind of makes things a little simpler and they can kind of start to get direction a little bit more. If you have a thing that does your kind of up-down alerting, tell me when a server goes down, or when an API node goes down, or when a disk fills up. Something like Nagios, for example, since that's one that's rather popular. There are OpenStack plugins out there on Nagios Exchange and Monitoring Exchange and those kind of places that you can go find. People tend to write their own for things that they really care about or things that are specific to their infrastructure, but there are certainly some reference ones out there. Then the other bucket is kind of trending data collection. So generally this is something like statsd or collectd running on a server. Probably I see more collectd than anything these days. And almost always that gets fed into Graphite. There are other graphing engines for that as well, but Graphite's rather popular. Okay, logging and search. If you've ever run logging in verbose mode in OpenStack components in production, you have a lot of logs to deal with. This actually happened to me once when I kind of left for the night and I'd been debugging something and I'd used Puppet to turn on logging on all my services. Guess how much disk space I had the next day? It wasn't very much. Logs, there are a lot of them. Again, this is distributed systems. The logs are all over the place. That picture was kind of nice because they were all in one place. Reality is we're dealing with the forest and not the log pile here because they're scattered all over your data center across all those different nodes. So distributed systems do generate a lot of logs. And when you're trying to find the cause of an issue, going around and looking at each one of those syslog files on all 130 servers in your data center, not a good idea. Don't do that. So OpenStack in particular can be pretty verbose. There are settings to control the verbosity of the logs, but a lot of people actually do, believe it or not, run services in production with verbose and debug turned on because that actually turns out to be pretty useful when they are troubleshooting issues. I've seen it done more than once. And don't forget that you're also dealing with logs from all the other stuff in there as well, the databases, the RabbitMQ, all the other stuff. Heck, I know monitoring services that produce logs that people care about, right? So it's a lot of logs. So generally, you want to get those logs together. You want to be able to search them. You want to identify patterns with them. And then you want to be able to do some kind of visual analysis on them, right? So this is actually one of those places, again, where there's kind of a rare source of agreement. Almost all the clouds that I've worked with in the past, say, year or so are using the Elk Stack. So if you've never heard of Elk Stack, Elasticsearch, Logstash, Kibana, ELK, Elk, right? These are really popular open source tools. So Elasticsearch is what does search and analytics on your logs. Logstash is what gets them all into one place so that you can do that. And then Kibana is a visualization engine. There's kind of a cool case study, which I think Elizabeth was also involved in from the OpenStack CI team that's on the Elasticsearch website. And you can go click on that link and check that out later as well. But this is kind of one of those places where, again, there are plenty of other tools out there, but this is stuff that seems to be really popular among the clouds that I've worked with. Just off the top of my head, some others, people that run VMware often look at VMware's Log Insight product, kind of does some of these same sorts of things. That is not an open source product, by the way, but so that's why I haven't got it on a slide in an open source conference. But there are other alternatives out there. Okay, so I think we're running low on time, but I'm around for questions, and you can find me online. These slides are going to get posted to the All Things Open website. I'll stick them on SlideShare somewhere as well, maybe faster. Any questions?